Okay, let's do this question. The question reads, in this circuit, VO equals 2 volts. Find IS. So we know the voltage VO is going to equal 2 volts. What is the voltage VO? Well, we know the voltage VO is going to be the voltage across these two terminals here. But we know that's also going to be the same voltage across this 4 ohm resistor. So we know the voltage VO equals 2 volts, right? Okay, where do you want to begin with this circuit diagram? Well, let's look at it, right? Let's try to understand what's happening with this circuit. So we have a current source here. And this current source is going to go to this node right here. Now, when this current source enters this node, we're just going to assume that the current is going to flow in this direction here, and then it's going to flow in this direction here. I'm going to label this current I1, and I'm going to label this current I2. So once the current I2 flows in this direction, once it reaches this node, it has 2 paths it can travel. It can flow this way. I'm going to label this current I sub 3, and it can flow this way. I'm going to label this current I sub 4. So we know the value of the voltage across this resistor, which is going to be VO, which equals 2 volts. So can we find the current I sub 4? Well, we can, can't we? We know the current I sub 4 is going to be the current that flows in this resistor, but also in this resistor, because these two resistors are in series, which means they're going to have the same exact current flowing through them. So to find the current I4, I'm just going to say the current equals the voltage over the resistance. The voltage we know is going to be VO over R, which is 4. Therefore, I4 equals the voltage VO, which is 2, over 4. Therefore, we can say the current I4 equals 0.5 amps. Now, this isn't our answer, but this might be able to help us solve this problem. We know the current flowing through these two resistors is going to be 0.5 amps. Now, it's possible that we can find the source current I2 that's going to give us 0.5 amps. Now, before we find the source current, I'm just going to redraw this circuit and I'm going to combine these two resistors. So I know I have an 8 ohm resistor and a 4 ohm resistor in series. So when I recombine these two resistors, I'm going to have a single resistor with a value of 12 ohm. So let's redraw this circuit quickly. So let's just add in the current labels that we drew in the first circuit. So we know this is going to be I1. We're going to have a current I2 here. We know this current through this resistor is going to be I3, and this is going to be the current I4. Now we know the current I4 equals 0.5 amps. So because we know the current I4, which is 0.5 amps, we can find the source current, which is actually going to be the current labeled I2. We know I2 is going to be the source current. Why? Well, we know I2 is going to be the source current because this current right here is going to enter this node and split these two ways, which means I2 is going to be the source current for the current I3 and I4. So let's use current division, right? So we can write our current division formula as I sub 4, right, equals the current source multiplied by, we're going to say resistor 3. Now we know R3 is going to be this 3 ohm resistor, which is in parallel with this 12 ohm resistor that has the current I4 flowing through it. And we're going to have R3 plus R4. Now let's start to simplify this. We know I4 is going to be 0.5 amps. We're going to write 0.5 equals IS. Instead of writing IS, I'm actually just going to write I2 because we know this is going to be our source current. So we have I2. R3 we're going to write as 3 ohms. So we have 3 over R3 is 3 again. We have 3 plus 12, close brackets. When we start to simplify this, we have 0.5 equals I2 multiplied by 3 over 15. Now when we simplify this, we're going to get I2 equals 0.5 times 15 over 3. I2 equals 2.5 amps. Now this isn't the answer, but this might be able to help us later on. We know this current I2 is 2.5 amps. And if we know this current I4 is 0.5 amps, well, we know automatically if we say I2 minus I4, I3 is actually 2 amps. Now, we know the current I2. They want us to find the current IS, right? So I have a few situations where I can combine resistors. I'm just going to combine these resistors. I have this 12 ohm resistor and this 10 ohm resistor that are in series. I'm going to combine these two resistors. We have this 3 ohm and 12 ohm resistor that are in parallel. So let's just combine these resistors to simplify the circuit, right? So when I combine these resistors, I'm going to have 10 plus 12 is going to give me 22 ohm. We're going to have this current source here. This is going to be 2 ohm. And when we find the parallel equivalent resistance for these two resistors, we can say 3 times 12 over 3 plus 12. That's going to give us 36 over 15, which we can write as 2.4 ohm. So this resistor right here is going to be 2.4 ohm when we combine these two resistors that are in parallel. Now let's simplify this some more. We know these two resistors are in series, so let's just redraw this to have one resistor. So we can now redraw this to look like this. We know 2 plus 2.4 is going to give us 4.4 ohm. Now look what we have here, right? We have two resistors in parallel and we have a current source. So it's very important that we remember what they want us to find. They want us to find IS, which is this current source here, right? Now remember, when we combined these two resistors here, we don't know the current anymore, right? We don't have the current I3 or the current I4, but we still have the current I2 that's going to be flowing through this 2 ohm resistor, right? We still have this current I2. The only thing is it just won't split it anymore. So we won't have the current I3 or I4, but we will have the current I2. When we redraw this circuit again, we're also going to have this current I2 here, right? And we know what this current I2 is. This current I2 is 2.5 amps. So if they want us to find the current IS, which is the current in this source, and we have two resistors in parallel, and we know the value of the current flowing through one of those resistors, all we're going to do is use current division to find the current source, right? Now let me just redraw this. That way you have a better understanding and you can actually view this circuit the way you probably are used to seeing it. So we have this current source here, which is IS. We have a 22 ohm resistor that's going to be in parallel with that current source. And then we have a 4.4 ohm resistor that's also in parallel with that current source. So think of it like this, right? We know current is going to leave this source here. When current leaves this source, it's going to come to this node and it's going to split, right? We're going to have some currents coming this way. We're going to call that current I1. And some current is going to go this way. We're going to call that current I2. So the same thing is going to happen here. We're going to have a current I1 this way. So now that we have redrawn and rearranged these resistors, the same thing is going to happen. We have this source here. It's going to enter this node. Therefore, we're going to have some of the current coming this way. We're going to label it I1. And some of the current is going to go this way. We're going to label it I2. We know the current I2. So let's use current division to find the source current. We're going to say I2 equals IS multiplied by R1 over R1 plus R2. Now we know why we use the current I2, because that's the current we know. So we didn't use the current I1 because we don't know the current I1. So we know the current I2 is 2.5 amps. I'm just going to write that back. We have 2.5 equals, we have IS, which is the source current. R1 is going to be the resistor opposite the current we know. So because we know the current I2, we're going to use this 22 ohm resistor for R1. So we have 22 over 22 plus 4.4. When you start to simplify this, we get 2.5 equals the current IS multiplied by 22 over 26.4. Therefore, we can say the current IS equals 2.5 multiplied by 26.4 over 22. When you put that in your calculator, the current IS equals 3 amps. And this is what they wanted us to find. They wanted us to find the current IS, and that's going to give us the value of 3 amps. So this is how we were able to solve these types of problems. It's not hard, but you must be very comfortable in using different techniques to solve these types of problems. Sometimes you're going to have to label different things in these circuits that you redraw in order to really have a good understanding of what's happening, right? So for example, we had to draw in these currents, and we just started to combine resistors, and we were able to find for different things in these circuits. Now, some of these things can be helpful, and some of the things might not be helpful. Now remember, this is circuit theory. At times, we're going to have to analyze these circuits and solve for either currents, voltages, or resistance, and we might not actually need to find that. But you never know what you might actually need when analyzing these circuits, so it's always a good rule of thumb just to solve what you can solve and then work your way down from there. You never know what might be helpful later on while you're analyzing these particular circuits.